Welcome to Home Digital Academy. We are on page 17 of our chemistry book, which is in the description below. Our chemistry book, the PDF is in the description below. So the page 17 is having elements. So today we are going to study about elements. We are to know here elements is in the chemistry. But today I'm going to start with the first 20 elements. 20 elements kwezo eziri mu periodic table. Element esooka onongera wandikawo 10. Even here I'm going to write 10 elements. Now this will be our number 1. This will be our number, and O is standing for number. Now this is the element. Now the next one is going to be the symbol. The next one is going to be the electronic configuration. Now the last one is going to be the valence. Even the other way, you're going to have the number, you're going to have the element, you're going to have the symbol, and you're going to have the electronic configuration, and then you're going to have the valence. Today I'm going to talk about 5 things: number, element, symbol, electronic configuration, and the valence of these 20 elements. Now the first element number 1, is called the hydrogen. Now let us first write the elements. The second one is called the helium. The third one is called the lithium. Fourth one is called the beryllium. Fifth one is called the boron. Number 6 is carbon. Number 7 is nitrogen. Number 8 is what you know, that is the oxygen. Number 9 is fluorine. Number 9 is fluorine. Number 10 is neon. Then let us go on this side. We have number 11, which is sodium. Number 12 is magnesium. Number 13, you check the elements are all there. Number 13 is aluminium. It is aluminium. Number 14 is silicon. Number 15, it is what you call the phosphorus. It is phosphorus. Number 16 is what we call sulfur. It is a sulfur. Yeah, it is some people write it like this. Number 17 is chlorine. It is chlorine with the H. It is chlorine. Number 18, it is the Argon. Number 19 is potassium. It is potassium. And number 20 is calcium. Calcium. Now those are the first 20 elements, starting from hydrogen and ending with calcium. Now let us go on the symbols. The symbols are always, some of them are got from the first letters of the elements. For example, hydrogen is H. Now helium can't be H, it is H, then E. Don't add those letters. The first one is capital, the second one is small. Lithium is Li, L is capital. Beryllium, that is Be. Now boron is capital B. Carbon is capital C. Nitrogen is capital N. Oxygen, it is capital O. Fluorine, it is capital F. Capital F. Neon, it is capital N. Since we have N, so this is capital NE. Now sodium here, it is not S, because we have sulfur, which is S. So sodium is not S. It is got from natrium, which is Latin word, and we write sodium as natrium. So Na, that is our sodium. Magnesium, write M, don't write A, jump A and write G. Aluminium, write Al, these ones are capital. The first letter is a capital. Now, we have silicon. There is S for sulfur, so silicon is Si. Now, phosphorus, it is a P, capital, no other letter. Sulfur is S. Chlorine, you jump H, then write Cl, that's our chlorine. Argon, it is A. R. Potassium is not P, because you have P there. Then it is got from Latin. It is a K. Now, and calcium is a C, but we already have C on carbon, so it is a Ca. So those are all the symbols of the first 20 elements. That's how we get them. Now, next one, we are going to see the electron configuration. We always get the electron configuration from this number. The number element is where I got the electron configuration. But whenever writing an electron configuration, the first shell or the first orbit can only allow 2 electrons. So hydrogen is having only 1 electron. So we write 1, then you put those dots, meaning that there are other shells. So the dots represents another shell added on there. So the first shell of hydrogen is already having 1 shell, and that 1 shell having 1 electron, as we are going to see in the next episodes. Now, helium, it is having 2, and we said the first shell can only hold the 2, so I can put 2 on the first shell. That is helium. Now, lithium is having 3, but the first 2 can go on the first shell, and the last one, which comes to 3, goes on the next shell. So goes on the next shell, which is a 1. So it is 2 to 1. This is a electron configuration of O level. There is what we have, the P group, the whatever group, the D group. Those are in HSC. So I'm showing you the electron configuration of O level. Jenkolaga ya O level waliyo eya HSC, eya P blocks, D blocks, like that. So we are looking on orbits only, not blocks. Okay, now we go on the beryllium. Beryllium is 4, so you're having a 2 to 2. Boron is 5, so you're having a 2 to 3. Now carbon is 6, so you're having a 2 to to 4. Nitrogen is 7, so you're having a 2 to 5. Oxygen is 8, so you're having a 2 to 6. Fluorine is 9, so you're having a 2 to 7. Neon is 10. But let us go back. Whenever writing these figures, they will be giving the sum. If you add them, they always give you this figure. For example, on nitrogen, if I add 5 to 2, I'll get 7. On fluorine, this to this, 7 to 2, I'll get 9. So they always give you this figure where the element was got from. So the number of the element. So if this is 19, when I will write there, I add or get 19. So let us go on neon. Now, the first shell can only have 2 electrons. Now, the second shell, this one which you have 1, 2, 3 for that second shell. This is the first. The second shell or the orbit can only hold 8 electrons. 8 electrons. Meaning that if I write 2 to 8, I'll get 10. Because 2 plus 8 is 10. So this shell is full. If I go on sodium, which has 11, I can't write 2 to 9. Because this one can only hold 8 electrons. So if I go on sodium, I write 1, if I go on sodium, I write a 2 to 8 to 1. If you add 2 plus 8 plus 1, go back to 11. So sodium is having 3 shells. Whereas from here, from lithium up to neon, they are only having 2 shells. Is it okay? I hope I'm clear on what I'm explaining. Now, magnesium, it will be a 2 to 8 to 3. If you add, you get 12. To 2, you get 12 there. Aluminium, it is a 2 to 8 to 3. Silicon, it is a 2 to 8 to 4. Phosphorus, it is a 2 to 8 to 5. Sulfur, it is a 2 to 8 to 6. Chlorine, it is a 2 to 8 to 7. Argon, it is a 2 to 8 to 8. So we are having another third shell, which can also hold only 8 electrons. So the third shell here, shell yokusa tunayejjudde on argon. We don't, if you're writing potassium, you don't put a 9 here because those last shells are always having 8. Only the first one having 2, but others having 8, or they can get full if you have 8 electrons on that shell. So on potassium, I'll be having 2 to 8 to 8 to 1. If you add 8 plus 8, 16 plus 2, 18 plus 1, giving you 19. So here, these two having four shells. These ones from sodium to here having 3 shells. These ones from here to here are having 3 shells. Now from here, sodium up to there. These ones are having 2 shells. These ones are having 3 shells. These ones are having 3 shells. So these ones are having only 1 shell. So you have got me. So these two having one shell. From here, number 3 up to number 10, having 2 shells. Now from number 11 up to number 18, having 3 shells. Now from number 19 up to number 20, having 4 shells. So this one is 8 to 8 to 8 to 1. Sorry, to 2. If you add 2 plus 2, 4, and that one is 16, giving you 18. So that's how we write the electronic configurations. Now, next step, we are going to see how we write the valences. Now, valences are written depending on the number of the last shell. For example, here the last shell is having 1, so we write 1. Now, this one, the last shell is having 2 and can only hold 2. It means that the combining power of this element is 0. It is 0. Whenever you have the last shell full, then the combining power is 0. Now, this one is having 1. This one is having 2. This one is having 3. This one is having 4. This one, you don't write 5, but in the next lessons we shall see. You can be having 5, but in this lesson, we are not going to write 5. What we do, write 8, then you subtract that 5, then you go back to 3. Meaning that whenever you reach 4, then don't write the next number. You just write 8 minus that number. So here I'll get a 3. So here I'll do the same. 8 minus 6, I get a 2. 8 minus 7, I get a 1. 8 minus 8, I get a 0. Because I showed you when the shell is full, you always get a 0. As here, shell is full, get a 0. Shell is full, get a 0. Shell here is full, we are going to get a 0, as you are going to see. For example, now let us go to 11. 11, just write because it is not more than 4. 1, here, write a 2. Here, write a 3. Here, write a 4. There, write a 5. Here, you don't write a 5. You go back on this method. 8 minus 5 goes to 3. 8 minus 6 goes to 2. 8 minus 7 goes to 1. 8 minus 8, 0. Then here, you write a 1 because it is not more than 4. And write there a 2. If you want to program, it is a 0, 1, 0, 1, 2, 3, 4. Then you go back to 3, 2, 1, 0, 1, 2, 3, 4. Then you go back to 3, 2, 1, 0, 1, 2. That's all with our chemistry work. These are the 10 elements here. And the 10 elements there. So combine, adding 10 plus 10, we go back to the 20 elements on the periodic table, the first 20 elements. For more videos, please subscribe, because if you subscribe, it is you'll get the message, you get the notification, and you get another video. All the series will be there. Chemistry series are going to be there. Mathematics, physics. Those 3 subjects are going to be broadcasted on this YouTube channel. Thank you for watching. Goodbye.